Hello and welcome to this video tutorial. So this presentation focused on the problems involving stability and determinacy of structures. So last time we had already presented the criteria on evaluating the stability and determinacy of structures. So to have a recap, we had discussed that first we have a general criteria for beams and frames. So we'll just compare R to 3n, and there will be scenarios on this comparison. So the first is if your R will be equal to the 3n, then this will be determinate. Okay, and then if your R would be greater than 3n, this will be now indeterminate. Okay, and the difference or the excess of R to 3n is the degree of determinacy. So if R is less than 3n, this is unstable. Okay, so this is the general criteria for beams and frames. So aside from this criteria, we also have criterion for frames, beams, and trusses. So let us start for beams. We have to compare now R to that of the C plus 3. Okay, C plus 3. And again, we will be having 3 scenarios on this one. So the same, if we have equal, we have a determinate beam. Okay, so if we have a greater than comparison, we have indeterminate beam, and if we have less than, this is unstable. So for indeterminate, we'll just have to get the difference or the excess of R to C plus 3 if ever that R will be greater than C plus 3. So R here actually is the number of reactions, and here is the number of parts wherein you wanted to cut the section into 2 parts, 3 parts, or just simply consider the whole structure, so that is only a 1 part. Okay, so C here is the coefficient of internal reaction, wherein if we have a roller, C is equal to 2, or the internal reaction coefficient, C is equal to 2 for the roller, and C is equal to 1 for a pin connection, or generally it on a hinge support. So that is for beams. Moving on to the frames. So for frames, again, we will have a comparison between 3B plus R to that of 3J plus C. So there will be again 3 scenarios here. 3B plus R comparing to 3J plus C. So similarly, we have those assumption. So this is determinate, indeterminate, and unstable. So lastly, we have the criteria for trusses. So the criteria for trusses is just comparing D plus R to that of 2J. Okay, so there will be three assumptions. So again, similarly, with a unequal comparison, this is determinate, and if we have a greater than comparison to the left to the right, to left to right to the right equation, then this will be indeterminate, and if it is less than, of course, this is unstable. So what is J here? J is the number of the joint. Just have to count that one. Similar to this J here on the frames. And C here is similar also for the C here, or the internal reaction coefficient. And then J here is the number of joints. B here is the number of members, or the number of bars. So let us now proceed to a concrete example involving this criteria. So let us have problem number 1. Say if we have a beam here, sorry, this is a frame. If we have here a support, and say another support here, a pin support, wherein this support will just intersect that one. See, let us represent that by other color. Say this support will intersect that one. So this is obviously unstable. Why? Because the supports will intersect, or will be concurrent at a certain point. Okay, so it may be that your reaction here, or the result of the reaction of the pin, could not direct this way, but of course, if your reaction here is a roller one, so we're gonna change this to a roller. So meaning the reaction will just be this direction, following the direction of the, or perpendicular to the direction of the roller. So being projected up to this point, see, this is A and B, so we do not need to count any reactions and then count the number of joints or the members, because we are quite sure that the projection of the reaction at the roller here will be concurrent, or will meet at one common point B. Okay, so this is assumed to be unstable. Okay, so let us have another example. Say number 2. So for the second example, if we have here another frame, and then this is supported by two hinges. Say we have two hinges there, and then there will be an internal hinges here present at this member. Let us now investigate what is the determinacy of this beam. So if we have an internal reactions present on a structure, of course we will refer to the expression with the variable C, and C is the internal reaction coefficient. Okay, so this is a beam. This acts as a beam, so therefore our criteria is that R will be compared to C plus 3. So looking at the figure, we have two hinges. Recall that C is equal to 1 for a single hinge. Okay, for a single hinge, C is equal to 1. But in this case, there are two hinges, so therefore our total C is equal to 2. Okay, so this is our C for the two hinges. So let me note here that C is equal to 1 for a single hinge. Alright, so now we're going to count the reaction. Of course, if we have a pin connection, there will be two reaction, horizontal and vertical. So all in all, we have 4 reactions. So we set that R is equal to 4. We will now have the comparison. So R here is 4 to be compared by C plus 3. C is 2 plus 3. So we have 4. This is 5. In short, we'll be having here 4 is less than 5. So if this is the case, again, this is unstable. Okay, simple as that. Okay, number 3. So for number 3, let us consider here. See, this is horizontal beam connected to a vertical member here, so the connection is rigid. Okay, say we have here a pin connection, and here we have a roller type. Okay, so we do not have any C here, therefore we'll just have to note that C is equal to 0 because we do not have any internal reactions there, so we do not have any internal coefficient. So next is to determine the reaction. So there are 2 here and another one here for this roller, and as we can see, the system of forces will not intersect, okay, at one common point. So only this one. Of course, this is a single reaction containing 2 reactions. However, this is not intersecting to both of these reactions. Okay, so therefore C is equal to 0 since we do not have any internal reaction here. So we could easily compare R to C plus 3. R here is 3, so 0 plus 3, therefore 3 is equal to 3. And if we have an equal comparison, equal result of comparison, therefore this is statically determinate. That is statically determinate. Okay, may we have another one? How about if we have here fixed support at both ends? Say we have here a beam that is restrained at both ends. Okay, so whatever the loading is, we do not have any internal reactions there. So we'll just have to indicate that there will be 3 reactions at fixed supports. So it's obvious that R here is 6 compared to C plus 3. So we have here 6, C is 0. So therefore C is being compared now to 3, and obviously C is greater than 3. So if it is greater than, then we'll have a notation here, statically indeterminate to the third degree. Why third degree? Because we'll just have to get the difference or get the excess of R to C plus 3. Okay? Okay, for another example, say we have here the same beam that is restrained both ends. Okay, but there will be, okay, let us put here an internal hinge. See, let us indicate that to be hinge. Okay, so we'll just employ this comparison. So when we have a fix, there are 3 reactions at each of the fixed connection, and then identify what is the value of C. C here is equal to 1, and there will be 1 hinge, so C is equal to 1. 1 times 1, that is 1. So therefore R will now be compared to C plus 3. So there are 6, sorry, there will be 6 reactions here, and then we have 1 plus 4, and then 6 is greater than 5. So I think this is 1, sorry, that should be 3, sorry, we have here 3, so this shall be 4. Okay, so what is our verdict? So 6 is greater than 4. We can now say that this is statically indeterminate to the second degree. Okay, the second degree. So again, we just get the difference or the excess of r2 dot c plus 3. So let us have another example. If we have a beam say this beam here is fixed at this end, and then we will find here a roller support, and then resting on this roller support is another member, and this is pinned at the end. Okay, so we have here an internal roller. See, we just label that as internal roller. So same procedure. Again, we are going to have to indicate the reactions here. There are 3, and there will be 2 here. Okay, 2 reactions there, and then all in all, the value of R is 3 plus 2, that is 5. Okay, and what is C for an internal roller? So we have said that C is equal to 2 for an internal roller. So we are now ready to compare R to C plus 3, and we have here 5. This is 2 plus 3. So it is obvious. You can see now that 5 is equal to 5, and the verdict for an equal result of comparison is this is statically determinate. Again, what do we mean by statically indeterminate? It is solvable by the 3 equilibrium equations. Okay, moving on to another problem. See, we have a 7 problem. Okay, so for the 7th problem, we have a beam that is restrained at one end. So if this is restrained at one end, it is called an overhang. If we're going to add here a roller at the edge, this is what we call prop beam. And then if we're going to add another one here, then we must have to evaluate now for its determinacy. So this is not an internal roller. Okay, so we do not have any internal reaction here, so there will be no internal coefficient. Okay, so the same procedure. Okay, so obviously R here is 3 plus 2, that is 5. Okay, so R now will be compared to C plus 3. Okay, so R here is 5. We have no value for C, therefore 5 is greater than 3. So therefore this is statically indeterminate to the second degree. Okay, so let us have another one. see problem number 8. So if we have here a beam, having a pin here on the edge and a roller at the mid span, and then another member here connected. So here we have a pin connection. Okay, so this is connected by an internal hinge here. So we're just gonna label that to be internal hinge. So we follow the process. So for a hinge external reaction, we have two. We have a single one here, and we also have two there. So all in all, R here is 3 plus 2, that is 5. And our C for an internal hinge is 2. Okay. So basically, if we are going to compare that now, our C plus 3, R is 5, C is 2 plus 3, that is 5, is equal to 5. So again, we have to put our judgment that this is statically determinate. Okay. So if we have the same beam, say for example, we have the same beam here, same as number 8. We have here an internal hinge here. We'll just have to explore if we are going to replace this reaction to a roller. Okay. So it's the same. This is a pin connection. So for a roller, we have here one, another one. There are two here. So therefore, R here is equal to 4. So C here is 2. So what will happen to your comparison? R to that of C plus 3. We have 4. 2 plus 3. 4 is less than 5. So this is unstable. Okay. Do not place here statically unstable. So just simply unstable. Okay. So why is it that this makes this roller here had made this beam to be unstable? Because if we are going to have here a loading, for example, a loading like this, of course there will be a horizontal force there, will tend to hinge this one. Okay, we'll swing this one because this roller here is free to move sideways. Then there will be a displacement or a movement on this direction, and of course this pin will just swing, okay, as well as this pin connection there. That is why this structure is already unstable. Okay, so let us have another example. Say number 10. If we have here a beam, this is fixed here and then somewhere here we have here a roller, and let's indicate this by a red. This is internal pin. Okay, and then we have here a fixed connection. At the same time, there will be a cable here. Okay, there will be a cable. So if we wanted to get the FBD of that one, we have, okay, indicate this to be 3, single reaction here, and then the cable is counted as one reaction, okay, because it is attached also to the beam. So remember that. So this will be another 3 sets of reaction. Okay, so all in all, how many? 3, 4, 5, 6, 7, 8. So there will be 8 R, and then C for this internal pin here is equal to 2. Okay, so we now compare R to that of C plus 3. So C here is internal pin. Let me correct this one. If we have an internal pin, it should be equal to 1. Okay, so we have here 8, 1 plus 3. So 8 is greater than 4. So our verdict, we just write here that this is statically indeterminate to the fourth degree. All right, so I think we have 10 sets of example for beam. So perhaps that will be a great number of example for that. So moving on to the frames. Okay, so for frames, we will just compare three B plus R to that of 3J plus C. So if we have here a number 1 frame, simple frame here that is fixed at both columns using this criteria, B here is, there are 1, 2, 3 bar members, and then reaction, obviously we have 3 reactions for each of the fixed connection. Okay, so R here is equivalent to 6, and then J, or the joint, is 1, 1, 2, 3, 4. So there are 4 joints. C here is 0 because we do not have any internal reaction. So we have here now 3B plus R, and 3J plus C. Bar is 3, R is 6, joint is 4, that is 0. So 3 times 3 is 9, plus 6, this is 12. So 9 plus 6 is 15. 12 is less than, or 15 is greater than 12. So our evaluation is this is statically indeterminate to the third degree. So let me present if we are going to use the general criteria for beams and frames, that is R compared to 3N. So I'll just consider this as a single segment. So therefore, the number of parts will be equal to 1. So this formula actually, it is depending on you whether you wanted to divide your frame into how many parts and then just count the accumulated reaction. So in this case, I'll just consider the whole structure. So the reaction here is 3 plus 3, that is 6. 3 times 1, that is number of parts. So therefore, 6 is greater than 3. So again, we will go back to this judgment. Okay? So if you wanted also, if you want to do a an exhibition solution wherein you wanted to divide this frame into two parts. Okay, so if you divide that into two parts, of course, you also cut the members where the cut section passes through. So if we are going to cut the members, we have 3 reactions here, just the same for the fixed connection. And cutting that one, of course, there will be 3 reactions here. There will be also 3 reactions there. However, as an action and reaction forces, the moment here is the same for the moment at the left portion, as well as the horizontal and the vertical here is the same with the vertical and horizontal at the left portion. So meaning this is just counted to 3 reactions, 3 reactions there, and this is 3. Okay, so all in all, we have R is equal to 9. For the number of parts, we have N. You have divided into 2 parts. So therefore, comparing that one, R to 3N, we will be having, this is 9. 3 times 2, 9 is greater than 6. So again, it will yield back to this conclusion. So this is statically indeterminate to the third degree. So again, it depends on how you use the formula. If you wanted a simple solution, if you wanted to have a complicated one, it's up to you. It is based on your convenience. Okay, but you can also use that both criteria, 3b plus R, 3g plus C, or you may wanted or opt to use R comparing to 3N. Okay, so that's it for the first problem. Okay, so let us try another one. Say we have here a framing system. say we have here a pin connection, fix, and another fix connection there. So we will have a solution comparing the two criteria involving frames. First, we have three. First criteria is we have 3b plus r to be compared to 3g plus c. So how many bars do we have here? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 bar members. So B here is equal to 10. The reaction, we have 3 here for the fix, another 3 for the fix, and 2 here for the hinge. So 3 plus 3, 6, plus 2, 8. So we have here R is equal to 8. And then there will be how many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 joints. And obviously we have no internal reaction coefficient. So 3 times B plus reaction 3, 9 plus 0. So this is obviously 38 and this is 27. So our verdict, 38 is greater than 27. So this is statically indeterminate to the 11th degree. So 38 minus 27 is 11. So this is statically indeterminate to the 11th degree. Okay, so as an alternate solution, if we wish to divide this into 3 parts, say this is the first, second, and the third part, we will have to cut the sections. Okay, so section 1, so here it is. Section 2, and section 3. So when we cut, of course we must have to indicate the internal forces in it. Okay, so let us write this reaction as it is, and then the internal reactions. Of course there will be 3 here, same true with this one, same true with this one. Three reactions also here. So whatever the reaction here will just transfer to this, and another 3 here, another 3 there. Okay, so this is 3, this is 3, this is 2, this is 3, and this is 3. So there are how many 3? 1, 2, 3, 4, 5, 6. So 6 times 3, that is 18, plus 2, that is 20. So R here is equivalent to 20. And the number of parts is 3 parts. So we are going to compare now R to 3N. This is 20. 3 times 3, 20 is greater than 9. 20 minus 9, 11. So it is statically indeterminate to the 11th degree. So it is up to you, again, to choose what is convenient to you, whether you wanted to employ the comparison of R to 3N or this one, 3B plus R, 3J plus C. So it is not a guarantee that there will be a superior solution between these two, because sometimes it is convenient to use 3B plus R, 3J plus C in a certain problem comparing to R to 3N. Or sometimes this R3N is much convenient to this. So there will be no superiority between the two. But of course, if we have an internal reaction, C, then we will be having no choice but to use this. Okay? So let us try another example. Okay. So we will employ this formula 3B plus R, 3J plus C. Our number of bars, let us count the number of bar members. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bar members. And how many reactions? So for a fix, this is 3. This is 2 for the hinge. For the fix, another 3. So all in all, we have 3, 6 plus 2, that is 8. So the reaction is 8. So we have 3 times 8 plus 8. And how many joints? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 joints here. Okay, let us write that one. 8 joints. So therefore this is 3 times 8. Of course, C is 0. So we have here 24 plus 8, that is 32. Compared to 24, 32 is greater than 24. So therefore this is statically indeterminate to 8 degree. 32 minus 24 is 8. So the excess is 8. Therefore this is statically indeterminate to the 8th degree. Okay, so I think those examples would be enough for you for the frame. So again, we can use 3B plus R comparing to 3J plus C, or R to be compared with C, or sorry, R would be compared to 3N. Okay, so that is an examples for the framing system. Okay, so moving on, let us now have examples for trusses. So for trusses, the criteria is we're going to compare, B plus R to that of 2G. So if we have a truss here, for example, we have a complex truss here, say simple truss that is connected by a series of trusses also. Okay. And this is okay, hinge here, and then another hinge is connected there, and then this is hinge connected. Perhaps we can now count our B. So our B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 number of bar members. Okay. So for R, we have 2 here, another 2, and another 2. So all in all, we have a reaction count of 6. And then as for the joint, we'll be having how many joints? 1, 2, 3, 4, 5, 6, 7, and 8. So J here is 8. Okay, so proceeding to this comparison. So this is 10. This is 6. This is 2 times 8. So we have an equal result. So therefore, this is statically determinate. Alright, so that's for the trusses. So let us have another one. Say we have here a yes, simple truss. So this is pin connected, this portion. Okay, another pin connection here, and another pin connection here. Okay, so we have here B plus R compared to 2G. So let us count B. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there will be 9 bar members. Okay. As for the reaction, let us just indicate the reactions again. There are 2 here, 2 there, and another 2 for those pins. All in all, we have an accumulated reaction of 6 reactions. Okay. So as for the number of joints, we have 1, 2, 3, 4, 5, 6, 7 joints. Okay. J is equal to 7. So therefore, we have B, 9, plus the reactions, 6, 2 times 7. Okay, so we have 15 is greater than 14. Therefore, this is statically indeterminate to the first degree. Okay. So with these examples on trusses, I think You can now manage to apply this criterion B plus R 2G. Just count the bar members, count the reactions, count the joints. Okay, so that is for trusses. So that's it for this video tutorial on determinacy and stability of structure. So thank you. So goodbye and have a more practice.